Welcome back, everyone. I am absolutely thrilled to have you here today. If you're as obsessed as I am with understanding exactly how elite, high-performance machines manage to pull off the impossible, well, you're in the perfect place. Today, we're zooming in on a true icon of the track, the Kawasaki Ninja Zx10r. Specifically, we're going to unpack the brilliant, downright aggressive engineering behind its world superbike-derived engine. We're going to break down the exact mechanical secrets that make this inline-4 configuration such a world-renowned powerhouse. So, let's get right into it. 213. Just let that sink in for a second. That is the peak horsepower this machine can generate at 13,200 RPM when the ram air system is fully engaged. We aren't just talking about a fast motorcycle here. We're talking about a precision-engineered missile designed to literally dominate the asphalt. But, it begs the question, how exactly does it produce that much sheer power without just tearing itself to pieces? Okay, let's dive into this. Here's our roadmap for today's explainer. We'll start by looking at the core engine specs, then explore how it breathes at 14,000 RPM, followed by thermal management, trackside shifting, and finally, we'll wrap up with 3 actionable pro tips for race teams. First up, the 213 horsepower power plant. To really understand its power, we have to look at the foundational architecture. So, the heart of this beast is a 998cc liquid-cooled 4-stroke inline-4, meaning all 4 cylinders are lined up perfectly straight. But pay special attention to the bore by stroke. It sits at 76.0 by 55.0 millimeters. This is what we in the biz call a short stroke design. By keeping that stroke incredibly short, Kawasaki allows this engine to rev insanely fast. Couple that with a highly compressed 13.0:1 compression ratio, and boom, you get our massive peak outputs, 213 horsepower, and roughly 114.9 newton meters, or about 84.7 pound-feet of torque at 11,400 RPM. And because of that short stroke design, we arrive at this totally critical number, 14,000 RPM. That's the extreme red line this engine can safely sustain. I mean, think about the violent, chaotic physical forces happening inside an engine block when pistons are firing over 200 times every single second. It's mind-boggling. It poses a massive engineering question. How does it handle that immense physical stress? Which brings us to our second section, breathing at 14,000 RPM. Let's take a look under the microscope at the valve train and intake. Now, what's really interesting here is how Kawasaki solved the high RPM stress problem. Instead of a traditional, heavier tablet layout, they pulled a solution straight from world superbike racing, finger follower rocker arms. This brilliantly engineered system actually reduces valve train mass by about 20%. And that 20% reduction, that's the secret sauce. That's what allows the engine to safely hit those 14,000 plus RPMs and lets teams run much more aggressive camshaft profiles. Simply put, lighter parts equals less inertia, which equals higher, safer revs. But, they didn't stop there. The cylinder head uses lightweight titanium for both the intake and exhaust valves. Why titanium, you ask? Because at extreme red lines, your standard steel valves literally cannot close fast enough. That causes a catastrophic condition known as valve float, and nobody wants that. Titanium completely prevents it. Plus, you've got 47mm electronic throttle valves. It's a full ride-by-wire system, meaning the engine control unit, the ECU, is electronically delivering the absolutely perfect air-fuel mixture for instantly crisp throttle response. And this perfectly illustrates how aerodynamics directly contribute to raw, unadulterated horsepower. The ram air intake is this massive duct right on the front cowl. As the bike accelerates, this duct literally forces cool, dense air directly into the airbox. It acts exactly like a supercharger. The faster you ride, the more air you cram into the engine, literally force-feeding it to push you to that incredible 213 horsepower mark we talked about. All right, moving on to section 3, beating the track heat. Let's look into cooling and lubrication. Thermal management is a massive hurdle. To solve this intense heat buildup, Kawasaki installed an independent air-cooled oil cooler. And this isn't just integrated into the main radiator. No, it's a dedicated, separate unit inspired entirely by their factory race bikes. So the crucial point is this. Keeping your engine oil temperatures stable isn't just about protecting the engine from blowing up. It is the absolute only way to prevent power fade during brutal, sustained track sessions. If the oil gets too hot, you bleed horsepower. This cooler makes sure that doesn't happen. And alongside that serious external cooling, there's some brilliant thermal management happening internally too. The cylinder bores themselves feature a highly specialized coating to minimize friction and heat buildup. So you've got the independent oil cooler managing temps on a macro level and specialized internal coatings fighting friction down at the micro level. It's a fantastic 1-2 punch. Section 4. Lightning-fast trackside shifting. How does all this power actually get to the wheel? Well, if you ever needed absolute proof that this motorcycle was built purely for the track, just look at the cassette transmission. This 6-speed layout lets race teams completely swap out gear ratios right there at the track without having to split open the entire engine crankcase. For mechanics in the pit lane, this is a total game changer. It dramatically reduces downtime. You can tune the bake's gearing for a tight, twisty track in the morning and completely swap it out for a long, high-speed track in the afternoon with zero drama. Mated to that brilliant transmission is the clutch. While a standard clutch has a super heavy pull and, quite dangerously, risks wheel hop when you downshift hard, the Zx10r uses an assist and slipper clutch to solve the problem. It gives the rider an exceptionally light lever pull, but much more importantly, the slipper function mechanically prevents the rear wheel from locking up or hopping during aggressive downshifts when entering a tight corner. It keeps the whole chassis perfectly stable when you are pushing the absolute limits of your braking. Okay, so we've covered some incredibly impressive specs today, from finger follower valves to cassette transmissions. But theory is one thing, right? Application is a whole different beast. So I want to ask you directly, how can professional mechanics and race teams actually maximize this world superbike technology on track day? Let's move to our final section and see how this all builds into actionable insights with 3 pro tips for teams. If you're running this machine, here is your playbook based strictly on the engineering. Step 1. Fuel for compression. You absolutely must use high-octane fuel to properly support that massive 13.0 to 1 compression ratio. Anything less, and you're just leaving power on the table. Step 2. Swap cassettes swiftly. Don't settle for the factory gearing. Truly utilize that cassette gearbox to perfectly adapt your ratios to specific tracks. It saves hours of labor since you don't have to split the crankcase. And step 3. Run aggressive cams. Because Kawasaki gave you that WSBK-derived finger follower system with 20% less mass, you have the mechanical headroom to tune the engine with highly aggressive camshaft profiles safely. Exploit that lighter valve train for everything it's worth. From the ram air forcefully feeding a short-stroke inline 4 to those titanium valves dancing at 14,000 RPM, the Zx10r is an absolute masterclass in friction reduction and thermal management. So, the ultimate question is, with pure world superbike engineering packed right into your pit lane, what will your next lap time be? Thank you so much for joining me today to unpack this incredible machine. Keep learning, keep pushing the limits, and I'll catch you on the next explainer.